In 1992, two astronomers surveying the space beyond Neptune came upon a clue. It was a mountainous chunk of orbiting ice. They had found the first Kuiper Belt object, or KBO.
The Kuiper Belt is a region where the small ice mountains that we were talking about actually started accreting and building into larger things. That's really, to me, the region we need to look at, because what happened there is planet formation started there, and it was frozen in some intermediate state. And trying to understand that will let us know in more detail how the accretion process started, but what shut it off is also going to be interesting and tell us something about the process as well. So to me, the future really lies in the outer part of the solar system.
Since 1992, astronomers have cataloged nearly 1,000 Kuiper Belt objects. 4 of them are pairs of objects circling each other, like Pluto and its moon Charon.
Pluto was discovered in 1930, right? And it was the oddball of the solar system. Most of the planets are in nice circular orbits, not Pluto. Most of the planets sit in this plane that represents the accretion disk, not Pluto. And it was just an oddball. It was small and icy and had no similarity to anything else that we really knew about.
Pluto and Charon lie at the inner edge of the Kuiper Belt. They are so different from their nearest planetary neighbors, Neptune and Uranus, that astronomers now believe they too are Kuiper Belt objects. Even more fossil worlds have come to light in the Kuiper Belt. Like Quaoar, at 1/10 of the Earth's diameter. The estimates are that perhaps 70,000 such relic worlds lie out in the Kuiper Belt. All survivors of the violent birth of the solar system. Since Hal Levison's visit to Meteor Crater, he's worked out a new theory about the formation of Uranus and Neptune. The lost worlds of the Kuiper Belt may hold the answer.
My thing is the orbits of the Kuiper Belt objects. Now, when Kuiper Belt objects formed, we believe they formed in nice circular orbits around the sun, all confined to a very narrow plane. But the Kuiper Belt that we see today is dynamically very excited. They're objects on high eccentricity orbits, which means they get close to the sun in part of the orbits and then far away, or their orbits are tilted with respect to the plane of the planets. How those objects came to be on those orbits are the clues that we can use to try to detangle the final stages of planet formation in that region of the solar system.
Levison took the eccentric orbits of the known Kuiper Belt objects and loaded them into his computer model. He then ran those orbits backward for several billion years. The model said that for the eccentric orbits to exist today, Uranus and Neptune, in red, had to form between Jupiter and Saturn, in blue, and move out to their present positions. That changes everything.
Why the Kuiper Belt is so exciting is because we can use it sort of as a crime scene, where we can use forensic science to try to figure out how Uranus and Neptune formed. The orbits, the composition, the sizes of the Kuiper Belt objects all give us important and vital clues as to what happened in the outer part of the solar system.
Computer models are one thing, getting up close another. Ground-based observations of Kuiper Belt objects don't give us much to look at. There is a mission called New Horizons set to go to Pluto and into the Kuiper Belt beyond. It will arrive sometime around 2015.
We do not have to wait 10 years in order to see a close-up picture of a Kuiper Belt object. Every once in a while, the gravitational effects of all the planets added together will knock an object out of the Kuiper Belt. And then it sort of slingshots around the solar system as it scatters off the planets. And eventually some of them, roughly a third of them that get out of the Kuiper Belt, actually end up coming into the inner part of the solar system, where we see them as comets. And as we learn more and more about these objects, we're really learning more and more about the Kuiper Belt.
a few comets make it to the inner solar system. Some of those slingshot back out into the Kuiper Belt on an endless round trip. Still others make a single trip, colliding with one of the inner planets or diving straight into the sun.
In a sense, we're simulating something like the surface of a comet. We basically, in this chamber, can simulate the pressure, which is almost zero. It's a vacuum. We can simulate the radiation, which tends to have lots of like hard UV, cosmic rays, really nasty things that people don't like, but no interest in chemistry. And also very low temperatures. We have a cooler here that can cool our samples to almost absolute zero.
Scott Sanford may not have to simulate the surface of a comet much longer. A spacecraft called Stardust is on its way back to Earth from Cometville 2 with a precious cargo. In December 2003, it flew very close to the comet and took these remarkable images of its core. More than that, it caught small fragments shedding off the comet. Sanford will soon have real stardust to work with.
Comets are probably the most pristine material we're going to find in the solar system that dates from the epoch of the formation of the solar system. So it's material that presumably actually was there and witnessed the whole formation of the solar system and has not been altered much since. They're our best guess at what the raw material, the raw building blocks from which everything ultimately was made. And so that's a real key bit of information if you understand how we got from there to here.
In the half-century since humans first escaped gravity into space, we've made a good start on our exploration of the solar system. We've sent probes to all the planets, to the asteroids and the comets. We've sampled the corrosive clouds of Venus and recorded planet-wide thunderstorms on its surface. We've survived dust storms on Mars and seen canyons that could swallow countries. We've mapped the icy moons of Jupiter and plunged into its atmosphere. We've skimmed the rings of Saturn. We've seen active geysers on the most distant and freezing moon in the solar system. But we're just at the beginning of our exploration. And only time will yield the secrets of the planets.